let's take a look at this paper. It is the grade 10 paper 2. Many of you have requested it, so let's try it out. Question 1.1, which of the following is an example of a chemical change? A, melting of ice. So the melting of ice is basically going from H2O to H2O. It's the same substance, so that is not a chemical change. The separation of nitrogen from air using fractional distillation. Here we're just removing nitrogen, so the nitrogen is still remaining nitrogen. That's not a chemical change. Dissolving potassium iodide in water. Well, potassium iodide is still remaining as potassium iodide, but just simply in an aqueous solution, so that's not a chemical change. Milk turning sour, on the other hand, is an example of a chemical change because that is a chemical reaction. It's changing the taste of the milk. Question 1.2, which one of the following is the correct description of a substance in the liquid phase? So A, the particles of the substance are bonded in fixed positions. So that's describing a solid. Fixed positions, they're not really moving much, so that is a solid. So A is out. B, the substance has a fixed volume but not a fixed shape. That is the correct answer because liquids have a definite volume no matter where they are. For example, 150 milliliters of water will always occupy a volume of 150 milliliters, whether it's in a bottle or whether it's on the floor. But the shape can change. Water or any liquid can change its shape. So the answer is B. Question 1.3, which one of the following has the largest atomic radius? So we know that atomic radius increases as you go down a period, or rather down a group. So 1.2 is B. Question 1.3, the atomic radius increases as you go down. So AR increases as you go down, and atomic radius gets smaller as you go across. So AR gets smaller. So we are looking for the one that is going to be somewhere in this region here, somewhere at the bottom. So you have beryllium, magnesium, neon, and argon. Neon definitely not, because neon is on the far right hand side. Likewise, argon is also going to be out. Beryllium is also on the right hand side of the periodic table, so that's also going to be out. So the option we're going to be left with is B, magnesium, because magnesium is on the left hand side. Question 1.4, which one of the following pairs of ions and atoms have the same number of electrons? Okay, so S2 minus, so that's essentially sulfur, and 2 minus means that it has gained 2 electrons, and argon. So let's refer to the periodic table. So sulfur is here. So sulfur has an atomic number of 16. That means it has 16 electrons and 16 protons. But S2 minus means it gained 2 electrons. So this has 18 electrons and 16 protons. And we were comparing it with argon. Now argon is here. So argon has an atomic number of 18. So it has 18 electrons and it has 18 protons. So we want to know which one has the same electrons. The answer is then going to be A. S2 minus and AR have the same number of electrons. So the answer here, A. Question 1.5, consider the balanced chemical equation for the reaction below. So we've got that. They tell us the number of oxygen atoms in the SO3 formed. So here, when 22.4 dm cubed of SO2 reacts with excess oxygen at STP is. Okay, so let's do this calculation. So since it is at STP, we can use the formula number of moles is equal to V over Vm. Now, the volume of SO2 is 22,4, and molar volume at STP is also 22,4, and so we have 1 mole of SO2. Now the question is asking about SO3, so we need to do a mole ratio. Now the mole ratio of SO2 to SO3 is a 2 to 2 ratio, which is essentially 1 to 1. So if I have 1 mole of SO2, I'm going to have 1 mole of SO3 forming. Now, if we want to calculate oxygen atoms, we're going to have to do the following. So we'll say that 1 mole of any substance contains 6,022 times 10 to the 23 particles. Now, if we are talking about 1 mole of SO3, it means we're going to have 6,022 times 10 to the 23 molecules of SO3. But you need to be careful because the question is asking about atoms. Now, in one molecule, so if you think about SO3, S, and then you have an oxygen, you have an oxygen, you have an oxygen. If this is one molecule of SO3 has 3 atoms of oxygen. So in order to get the number of oxygen atoms, we're going to multiply the molecules by 3. So the atoms of oxygen is going to be 3 times 6,022 times 10 to the 23. And so that corresponds to C. So the answer there is C. Now let's take a look at question number 2. A bag of cement has the following percentage composition by mass. 2.1.1, is cement a mixture or a pure substance? Cement is of course going to be a mixture. And the reason why it is a mixture is because it has different substances in it. Right? You have calcium oxide, you have silicon dioxide, and so on. Now, question 2.1.2, identify the type of chemical bond that forms when calcium and oxygen combine. So, calcium and oxygen, CaO. Calcium is a metal, oxygen is a non-metal, and so a metal and a non-metal will give us an ionic bond. Now, question 2.1.3, draw the Lewis structure for calcium oxide. So, if it's an ionic bond, it means that there's going to be ions, right? Now, calcium is in group 2. That means it is going to donate 2 electrons, and so it's going to have a charge of Ca2+. Oxygen is in group 6 or 16, depending on how you want to classify it. So group 6 or 16, and so it's going to have a charge of -2. So O2-. So essentially we have Ca2+ and we have O2-, and since these numbers are the same, we're not really interested in the minus or the plus right now. Since the numbers are the same, we can just join them together. So if we want to figure out what so this is going to be the chemical formula, CaO. And if we want to draw the ionic bond, then because this is going to be an ion, we'll use a square bracket. So Ca2+, and then the oxygen, we're going to have O, and then the 2- here. Now oxygen gained 2 electrons. So it's going to have the 2 electrons from the calcium. So there's the 1, there's the 2. And it's still going to have its 6 valence electrons that I'm going to represent using crosses. And so now oxygen has a full octet. There's 8 electrons around it, 2 that were taken from the calcium and the 6 that it already had. Then question 2.1.4, write down the name of the compound Fe2O3. So Fe2O3, Fe is iron, and then O3 is oxygen, but because it's at the end of the name, we change it to oxide. Now, if we wrote this, we wouldn't get full marks because remember that iron is a transition metal. And because it is a transition metal, it can have different oxidation states, different charges. So we need to figure out what the charge is going to be and represent that charge in a bracket. Now the simple way to do it is to switch this. So take this and move it across there, and take this and move it across there, meaning you would have had Fe3 plus and O2 minus. So the charge of the Fe would have been 3 plus. So in brackets we will put Roman numerals 3. So iron 3 oxide would be the correct name. Question 2.1.5, determine the number of calcium oxide particles in 750 gram sample of the cement. Okay, so if I have 750 grams of cement, what mass of calcium oxide do I have? So calcium oxide is 62% of that. So 62 over 100 multiplied by 750, and that gives me 465 grams of calcium oxide. Now from here I can calculate the number of moles. So the number of moles here is going to equal the mass divided by the molar mass. Now the mass is 465, and the molar mass of calcium oxide we get from the periodic table. So calcium has a mass of 40 and oxygen is 16. So 465 divided by 56 is going to be 8,3 moles of calcium oxide. Now, we can then calculate the number of, I want to say, formula units, right? Because we don't say molecules or atoms here because this is ionic, we say formula units. So 1 mole is 6,022 times 10 to the 23 formula units, right? So if we have 8,3 moles, that means we're going to have 8,3 times 6,02 times 10 to the 23 formula units of CaO. Now this simplifies, let me move on to the next page. So that simplifies to 5, 0 times 10 to the 24 formula units of CaO. Now you can think of a formula unit like a molecule if you want, but because it's ionic we don't call it a molecule. Now one formula unit is this, so this is a formula unit, of course with the electrons. So that's one formula unit. So one formula unit has one atom of oxygen. Oh, the question is asking about calcium oxide particles. So that is the final answer. Formula unit, this is the final answer. We don't need to go any more deeper. Okay, question 2.2. In a process called calcination, calcium carbonate, CaCO3, is heated to form the calcium oxide found in cement. The balanced chemical equation is given. So is this a synthesis or decomposition reaction? This is going to be a decomposition reaction, and for the simple reason that you have one thing that's breaking and becoming more than one. You have actually two things here. Question 2.2.2 is calcination an example of a physical or chemical change? So this is a chemical change. And then explain the answer. Well, this is a chemical reaction, right? So in a chemical reaction, you're going to have a chemical change. So chemical reaction, you have new substances or new molecules forming. Moving on here, question 2.3. Calcium carbonate reacts with hydrochloric acid to form calcium chloride, water, and CO2. Write the balanced chemical equation for the reaction. So calcium carbonate, they've told us, is CaCO3, and it reacts with hydrochloric acid, which is HCl, and that's giving us calcium chloride. So calcium chloride is CaCl2 plus water, so H2O, and carbon dioxide, CO2. Now we just need to ensure that this is balanced. We have a hydrogen here, we have two hydrogens there, so we'll need to put a 2 here. We've got two chlorines, carbon, we have a carbon there, 3 and 3. Yep, that's balanced. Now moving on, question 2.3.2, explain why tiny bubbles are noticed during this reaction. Well, we know that carbon dioxide is a gas, and because carbon dioxide is a gas, it's going to form bubbles. So the bubbles are due to the formation of CO2 gas. Question 2.4, equal volumes of oil, milk and honey were allowed to settle in a cylinder as shown in the diagram below. Define density, that's fine. Question 2.4.2, arrange the liquids from the lowest to highest density. So the lowest density is obviously going to be the highest up. So oil is the lowest density, then you will have milk because milk is in the middle, and then you will have honey. I think that was a pretty straightforward question. Question 3. The cooling curve of ammonia is represented in the graph below. The graph is not drawn to scale. Question 3.1. Write down the boiling point of ammonia. So 3.1. So because this is a cooling curve, we won't necessarily have a boiling point. However, we should know that the melting point of a substance is the same as the freezing point. So the temperature at which a substance is going to go from a solid to a liquid, meaning melting, is going to be the same temperature at which that same substance is going to go from a liquid to a solid. Likewise, the boiling point of a substance is going to be the same temperature at which that substance condenses. So is going to be the same as the condensation point. So if I'm examining this, I can see here, well, since it's a cooling curve, this is obviously going to be a gas, this is going to be a liquid, and then if there were a line going down, that's going to be a solid. So what we're looking for here is the temperature at which it's going to go from a gas to a liquid or liquid to gas, because as we know, boiling and condensation are going to be the same. So the temperature here is going to be minus 33,34 degrees Celsius. Moving on to question 3.2. Explain in terms of temperature, energy, and movement of particles the changes that takes place between point C and D. So between this point and this point, what's happening to the temperature? So the temperature is decreasing. Then in terms of the energy, the kinetic energy is decreasing as well, because remember that temperature and kinetic energy are related. The higher the temperature, the higher the kinetic energy, and vice versa. And movement of particles. If the kinetic energy is getting lower, the particles are moving less. So particles move less, or they move slower. Now question 3.3. Explain the change taking place between point D and E. So at this point here, this is where you are going to have a phase change. I call this a plateau. And at a plateau, you have a phase change. So we are going to have a phase change from a liquid, and then if we are to continue this, this would be a solid. So a phase change from a liquid to solid. Now question 3.4. At which region of the graph A to B or C to D are particles closer together? So A to B or C to D? So the answer is going to be C to D, I think quite clearly, because from C to D they are in a liquid state. So they are in a liquid state. But from A to B, they're in a gas state, and we know that particles in the gas are quite far apart. Now, question 3.5 says, the melting and boiling points of three substances is indicated in the table below. So we've got water, ethanol, ethanoic acid. So define melting point, that's fine. 3.5.2, which substance from the table has the weakest forces between the particles? So explain your answer. The answer here is going to be the one that has the lowest melting and boiling point. And so the answer here is going to be ethanol. Okay? And that's because it has the lowest melting point, and boiling point. Question 3.5.3, what is the phase of ethanoic acid at room temperature? So to answer this, I'm going to draw a number line. I'm going to put in the two values, so 16,6 and the other is 117,9. Then I'm going to write solid, liquid, and then gas. Now 25 degrees is between these two values. Room temperature is 25 degrees. So 25 is somewhere here. And so it matches up with a liquid. So the answer is liquid. Let's take a look at question number 4. The 3 stable isotopes of magnesium and their percentage abundance is indicated below. So we've got 24, 25, and 26. So 4.1.1, why does the atomic mass of M24 differ from that of M26? So what is the difference? Remember, isotopes are elements with the same atomic number but different mass number. And the difference in mass is on account of the different number of neutrons. So Mg26 has 2 more neutrons than Mg24. Question 4.1.2 says determine the relative atomic mass of magnesium. So the first thing we need to do is figure out the percentage for Mg26. So the percentage for Mg26 is going to be 100 minus 78,99 minus 10. And that's going to equal 11,01%. Now to calculate the relative atomic mass, or the RAM, you take the mass multiplied by the percentage and then add that to the next mass and its percentage, and then so on and so forth. So the first mass is 24 and its percentage is 78,99 over 100, plus next mass is 25 and the percentage is 10 over 100, plus the next mass is 26 and the percentage is 11,01 over 100, and that's equal to 24,32 AMU, or atomic mass units. Question 4.2, the following is an extract from the periodic table, refer to page 12. So they tell us define electronegativity, we are okay with that. 4.2.2 says describe the trend in electronegativity from left to right across the period. Now we have the electronegativity values in our periodic tables, and so all we then need to do is we need to read it. So electronegativity increases from left to right, so as you go across a period. Question 4.2.3, so they want us to explain why this occurs. Well, it has to do with something called effective nuclear charge, or in other words, you can think of it as the charge in the nucleus. So as you go from left to right on the periodic table, the nuclear charge increases, right? The nuclear charge increases. So you can think of it as the charge inside the nucleus, because there are more protons there. So the charge inside the nucleus gets bigger and bigger and bigger. So that's going to have an effect on the electrons that's around it, right? Because you have a greater positive charge, and so it's going to attract the electrons that are around it with a much stronger force. So the force of attraction between the nucleus and electrons around it. So that could be electrons that are directly on that atom, so in the orbitals around it, or it could be electrons that are in other atoms. So electrons around it increases. Question 4.2.4, no electronegativity value is indicated for neon. Why? Because neon is a noble gas, right? And that essentially means that it has a full outer shell, right? So full outer shell. So it essentially doesn't need to give off any electrons or take any electrons. So it's not going to bond with anything. Okay, question 4.3, use the balanced chemical equation to prove the law of conservation of mass. Okay, so let's work with the left hand side. So left hand side. So we have 2 times 3, which is 6 calciums. So 6, and the mass of calcium is 40 plus. Then we have 2 phosphorus, and then you multiply that by 2. So we have 4 phosphorus. So that's going to be 4 times, phosphorus has a mass of 31 plus, then let's look at the oxygens. So 2 times 4 here, let's neaten this up. So here we have 2 times 4, which is 8, and then multiplied by 2 there, so that's going to give me 16. So plus 16 oxygens, and that's 16 times 16. Then plus 6 silicons, so 6, and the mass of silicon is 28, plus, then I have 2 times 6, I have 12 oxygens, so plus 12 into 16, and that's going to give me a total mass of 980 grams per mole. Now let's look at the right hand side. So the right hand side, we have something similar. We have 6 calciums, so 6 times 40, plus we have 6 silicons, so 6 times 28, plus, and then we have 6 times 3 oxygen, so 6 times 3 is 18, so 18 times 16. And then we're going to add in here 4 phosphorus, so 4 times 31 plus, and then here we have 10 oxygens, so 10 times 16. Now, if you check the left hand side and the right hand side, you should have the same stuff. So here I have 6 times 40, here I have 6 times 40. I have 4 times 31, I have 4 times 31. I have 2 times 16, and I have 16 times 16. So that's going to be 28 times 16. And here I have 10 and 18, which is 28. And then here I have 6 times 28 and 6 times 28. So that's going to give me the same amount, so 980 grams per mole. Okay, now let's take a look at question number 5. Aluminium powder reacts with sulfuric acid, H2SO4, according to the following balanced equation. In one such reaction, exactly 5 grams of aluminium reacts with sulfuric acid of concentration 0.1 moles per dm cubed at STP. So we leave out 5.1. 5.2.1, calculate the number of moles of aluminium that reacted. So number of moles is equal to the mass divided by the molar mass. The mass of aluminium was 5, and the molar mass is 27. So that gives me 0.19 moles of aluminium. Question 5.2.2, calculate the volume of H2SO4 in dm cubed that reacted. So we know the number of moles here is 0.19, and then we can do a mole ratio. So the ratio of aluminium to H2SO4 is 2 to 3, and I'm getting that from my balanced equation. But I don't have 2 moles of aluminium, I have 0.19, and so then this will be X. Now we cross multiply, we're going to have 3 times 0.19 is equal to 2X. That means X is going to equal 3 over 2 into 0.19. So X is equal to 0.285 moles of H2SO4. Now that I know the moles of H2SO4 and I know its concentration, I can calculate the volume. So concentration is equal to number of moles over volume. So 0.1 is equal to 0.285 divided by volume. So volume is going to equal 2.85 dm cubed. You just rearrange, you take the V and switch it with the 0.1. Now question 5.2.3 says, calculate the volume of H2 gas that formed at STP. So H2, and we could use Al or we could use H2SO4. I'm going to use H2SO4 because it is a 3 to 3 ratio. So H2SO4 to H2, that is a 3 to 3 ratio, which is essentially 1 to 1. Now, we calculated that we don't actually have 1 mole of H2SO4, we have 0,285, and so this will also be 0,285 moles. Now, since this is at STP, I can say N is equal to V over Vm. 0,285 is equal to V divided by 22,4. Then V is equal to, now we cross multiply, we'll get 6,38 dm cubed. Now let's take a look at question number 6. A compound is made up of sodium, phosphorus and oxygen. A 10-gram sample of this compound consists of 4,21 grams of sodium, 1,89 grams of phosphorus. Determine the empirical formula. So the first thing we need to do is figure out the mass of oxygen. So we have a 10-gram sample, then we know that 4,21 is Na. We know that 1,89 is phosphorus. That means the balance must be oxygen. So the balance is going to be 3,9. Then the next logical step would be to calculate number of moles. So I will say that the number of moles for Na is going to be mass divided by molar mass. So 4,21 divided by 23, which is 0,18. Then for the phosphorus, the number of moles is going to equal 1,89 divided by 31, which is equal to 0,06. Then oxygen, the number of moles is 3,9 divided by 16, which is equal to 0,24. Then we need to divide by the smallest number. So the smallest number here being 0,06. So 0,18 to 0,06 to 0,24. We'll divide everything by 0,06. And this is going to give us 3 to 1 to 4. So that means I have Na3P1O4. And so that's my empirical formula. Question 6.2. 15,75 grams of hydrated oxalic acid is dissolved in water to make a 250 cm cubed solution of concentration 0,5 moles per dm cubed. Question 6.2.1, calculate the molar mass of this. Okay, so what we'll do here is we can use the formula concentration is equal to mass divided by molar mass times volume. So we know the concentration is 0,5. We know the mass of this thing, which is 15,75. We don't know the molar mass, that's what the question is asking for. And the volume is 250 cm cubed, which we need to convert, so that's 0,25 dm cubed. Now all you need to do is switch this and the m, and you can solve for m. M is going to equal 126 grams per mole. Then question 6.2.2, determine x. Now, it may seem a bit difficult, but it's actually not, because if we know the molar mass of this thing, then we can solve for x quite easily. So all we need to do here is we'll say that H2, so there's 2 hydrogens, each one with a mass of 1, plus there's 2 carbons and each one with a mass of 12, plus 4 oxygens, so 4 and each one with a mass of 16. And then we have X waters, so plus X, and the mass of water is 18. Now all of these masses is the sum of these masses is going to be 126. And now you just solve for x. X is going to equal 2. Now let's take a look at question 6.3. Question 6.3 says the reaction between lead 2 nitrate and potassium iodide is given by the balanced equation below. The percentage yield of lead 2 iodide is 75%. Determine the mass of potassium iodide required to form 80 grams of PbI2. So here what we need to do is first calculate the actual yield, right? Because if we want 80 grams of PbI2, you got to understand that some of it is going to be lost, right? So at the beginning, we're going to have some amount, right? 25% is going to be lost because you have a yield of 75%. And then the 75% that is still there is going to have a mass of 80 grams. So what we want to know is how much should you make at the beginning, and then we can work backward. So it's actually quite simple here. We'll start off by saying that 75% is 80 grams. That means 100% is going to equal something. Let's call it x. Now cross multiply here. You will get 80 times 100 is equal to 75x. Then you divide by 75, you divide by 75, you get x is equal to 106,67 grams. So this is the amount that you need to make of PbI2, and then 25% of it will be lost, and then we'll get 80 grams. So this is what we are working toward. So how many moles does this equate to? So we'll say the number of moles of this is going to equal the mass divided by the molar mass. So 106,67, and then the molar mass of PbI2 we get from the periodic table, right? And that's going to equal 461. So that's going to equal 0,23 moles of PbI2 that's needed. Okay, that's the amount of PbI2 that we need to form. So the question is asking the mass of potassium iodide, so the mass of this. So we do a mole ratio now. So Ki to PbI2 from the ratio or from the reaction is 1 here and 2 here. So if I need to form 0,23 moles here, I'm going to need double that. So this is going to be 0,46 moles of Ki that's needed. Now from here we can then calculate the mass. So we'll say that the mass is going to equal the number of moles times the molar mass. So 0,46 multiplied by the molar mass of Ki is 166, and that's going to equal 76,36 grams of Ki. So again, just to put this into context, 76,36 grams of Ki is going to give me 106,67 grams of PbI2. Now 25% of this will be lost, and then 75% is retained because that's the yield, and that 75% is the 80 grams that the question is asking us to produce. Now let's take a look at question number 7. Hydrogen gas is prepared from the reaction between methane and steam. The reaction is represented by the following balanced equation. The graph below, not drawn to scale, shows the volume of hydrogen gas formed when different volumes of methane reacts with excess steam at STP. 7.1, calculate the gradient of the graph. I mean, gradient is not too crazy. So 7.1, we'll do the gradient is equal to the change in y over the change in x. So I'm simply going to say 120 minus 0 divided by 40 minus 0, and that's going to equal 3. Question 7.2, what does the gradient of the graph represent? So if we want to work it out, we'll say that the gradient is equal to whatever is in the y-axis divided by whatever is in the x-axis. So the y-axis is essentially the volume of H2. So it's going to be V of H2 divided by volume of CH4. So this is V of CH4. Now this is a 3:1 ratio, right? It's a 3:1 ratio. So in other words, the volume of H2 divided by the volume of CH4 is equal to 3/1. Now if I cross multiply, I'm going to get volume of H2 is equal to 3 times the volume of CH4. And if you notice, this is from the reaction, right? It's the mole ratio or the volume ratio, right? So this is the volume ratio of H2 and CH4. It could also be the mole ratio. I mean, we don't have to go into it, but that's the basic idea. So in other words, if you want the volume of H2, it's going to be 3 times the volume of CH4. Moving on here, question 7.3. Between H2, yeah. Question 7.3, determine the volume of H2 formed when 72 cm cubed of methane reacts with excess steam. So, I mean, here all we need to do is do the use the ratio. So, if this is 72 cm cubed, what is this going to be? So if you look at it, from 40 to get to 120, you multiply by 3. So essentially then all you got to do is say from 72 to whatever that value is, you multiply by 3. So the volume of H2 is going to equal 3 times the volume of CH4. So 3 times 72, and that's equal to 216 cm cubed. Question 7.4, the total volume of gas formed when x cm cubed reacts with x cm cubed of CH4 reacts with excess H2O to form y cm cubed of H2 is 420 cm cubed. So total volume 420 cm cubed. Determine the values of x and y on the graph. Okay, so what we need to do here is we'll say, okay, the total volume that I have is going to be 420 cm cubed, right? Now from the reaction here, I can see that I have, for every one CH4, I will have 3 H2s. So I'll have an H2 here, I will have an H2 here, and I will have an H2 here. So all we need to do is we will divide the 420 in the ratio 1 to 3. 1 being the CH4 and 3 being the H2. So we'll say 420 times, now we add this, 3 plus 1 is equal to 4. So multiplied by 3 over 4, and that's equal to 315 cm cubed. So the 1 is the CH4. Rather, this is the H2 because it's 3 here, there's 3 of them. So this is going to be the volume of H2. Then we'll say 420 multiplied by 1 over 4, and that's going to equal 105. So there's 1 CH4, so this is going to be the volume of CH4. And that seems to be the whole paper. If you stuck around, everyone, please don't forget to leave a like, share, and subscribe. And good luck with your exams. I'll see you all in the next one. Bye-bye.